Hello guys, welcome back to the channel Mathemagix JEE. This is the part 2 of the discussion of the second mock paper for JEE Main 2025. We already discussed the part 1, which is section A, in a separate video. I will link that video in the description. You can check out that video after seeing this discussion. So let's begin our session. Here is the first question of the section B, which is of integer type. So it says, let alpha and beta be the roots of the quadratic equation this, okay? Let for all integers n greater than 0, Sn is defined like this. Then the value of this is asked, okay? So alpha and beta are the roots of this equation, where alpha is greater than beta, okay? So let us try to find the roots of this equation first. So we can write this as x equal to 32 plus minus root under, this will be 32 whole square minus 4 times 60, so 240 divided by 8. So it comes out to be this. If we calculate, 32 times 32 will be 64, then 96, it will be 210. So 1024 minus 240 will give us root under 784 divided by 8. Now 784, we can calculate the square root by this method. So 2 to the 4, then 3, 8, 4, then 4, then it will be 9, sorry, this will be 8 times 8, so 38, okay. So it comes out to be 28. That means the roots are 32 plus 28 divided by 8, which is 15 by 2, and other root is 32 minus 28 divided by 8, so half. So we can say that this is our alpha and this is our beta. So here Sn will be alpha square plus beta square divided by 2 whole to the power n. That is, if we calculate, 225 plus 1 divided by 4 divided by 2. So 226 divided by 4 into half whole to the power n, minus this will be 225 minus 1. So 224 divided by 4 times half whole to the power n. This is our Sn. So this, if we calculate, it comes up to be 113 by 4 whole to the power n minus 112 divided by 4 whole to the power n. This is our Sn. Now, how to find the value of this expression? We have to simply use Newton's formula for this. So, Newton's formula or Newton's identity, which states that if a quadratic is like this, ax square plus bx plus c equal to 0, and its roots are alpha and beta, then if Sn equal to alpha n plus minus beta n, then we can write that Asn plus bsn minus 1 plus csn minus 2 equal to 0. So here we can say that the roots of that quadratic, which will give us the value of Sn, is 113 divided by 4 and 112 divided by 4. So let us construct this quadratic first. So the quadratic will be equal to x square minus sum of roots, that is 113 plus 112 divided by 4 times x plus the product of roots. So 112 divided by 4, sorry, 16 equal to 0. So if we multiply by 16 here, we get 16x square minus this will be 225x plus this will be, if we calculate, sorry, this will be 225 times 4, that is 900, and this will be 113 times 112, so it comes out to be 226, then 113, then 113, so 12656 equal to 0. That means we can apply Newton's identity in this quadratic. So From here, we can say that Sn times 16 minus this 900 times Sn minus 1 plus 12,656 times Sn minus 2 equal to 0. So here, if we put the value n equal to 20, then we will get 16 times S20 minus 900 times S19 plus 12,656 S18 equal to 0. Now we are to calculate the value 4S20 plus 3164S18 divided by 15S19. So from here we can say that this will be 16S20 plus 12656 times S18 will be equal to 900S19. So if we take this in the left hand side, we will get 1, then it will be 900S19. Now if we take a 4 common here, we will get this will be, if we take the 4 common, then it will be 4 and this will be 3164. Now we can cancel 4 by this. So 4 times 225 is 900. So we have to calculate the value of this divided by 15s19. So here we can take 115 in the right hand side. So here it will be 15 and then it will be 15. That means the value asked in the question is equal to 15. So 15 will be the correct answer for this question. I hope you understood the concept behind this question. So let's proceed with the next question. Here it says, let G defined from R plus to R plus be an invertible function. Okay. So G inverse X exists such that for all X belonging to this interval, G dash X is greater than 0 and G double dash X is greater than 0. So from these informations, we can say that Gx is increasing as well as Gx is concave upwards. So the function may look something like this. Okay. And if area bounded by y equal to gx, x-axis, and x equal to 2 and x equal to 6 is 12 square units, then the area bounded by y equal to g inverse x, x-axis, x equal to 2 and x equal to 6 is what? Okay. So let us try to plot a rough graph for this function. So here is the axis. This is the function gx, let's say. So here will be 2 and here will be 6. This is y equal to gx, and this area is given to us as 12 square units. Now, how to find the function g inverse x? We know that inverse of a function is basically the reflection about y equal to x. So g inverse x will look something like this, the mirror image of this function. Now as x belongs to 2 to 6, so actually we have to plot these two graphs in between those points only. So let's say this is gx like this. So this will be the function g inverse x like this, the mirror image. So we are to calculate this area, this yellow area. This is the function y equal to g inverse x. Now how to calculate this? We can say that the area of this total region, let's say this is a, then a is equal to the area bounded by this function gx and x-axis from this point to this point, which is let's say a1, which is 12 square units, and then we have to add something. Now what is that? The added portion must be this. So by symmetry about the line, this y equal to x, we can say that this total area will be 2 times the area bounded by the function gx and x between these 2 points. So 2 times integral, this is 2 to 6. Then now as x is greater than gx, because gx is concave upwards in this interval, so x will be greater than gx. So we have to subtract gx from x minus gx dx from 2 to 6. So a will be equal to 12 plus 2 times. Now integral x dx from 2 to 6 will be half times. This will be 36 minus 4, so 32. Then integral 2 to 6 gx dx, it is equal to a1 itself. So a1, which is 12. So it comes out to be, this is 16. So 32, then plus 12 minus 24. So 32 minus 12, that comes out to be 20. So 20 is the correct answer for this question. I hope you understood the concept behind this question. This is the question number 23. It says the mean and variance of a set of 15 numbers are 12 and 14 respectively. Okay. So two sets are given, set 1 and set 2. Now set 1 has mean equal to 12 and variance equal to 14. Second set has mean equal to 14 and variance equal to x. So we have to find x if the variance of all the 13 numbers in the two sets is 13. So let us denote the elements of this set as ai and denote the elements of this set as bi. So summation ai will be equal to 15 times 12, so 180. So summation bi will be 14 times 15, that is 210. Now variance of all the 30 numbers in the set. Okay, so we can calculate summation ai square from this informations, that is summation ai square will be number of elements in the set times the variance of the first set, that is 14, plus square of the mean, so 144. That means it comes out to be 15 times, this will be 8, 15. So this much. Now summation bi square we can calculate, it will be equal to number of terms plus this variance plus square of mean, that is 196. So this much. Now the variance of the combined set will be sigma dash square, which is equal to summation ai square plus summation bi square divided by total number of elements, that is 30, minus new mean, which is summation ai plus summation bi divided by 30. So 180 plus 210 divided by 30. So 6 plus 7, that is 13. So here will be 13 square. Sorry, this root will be not there because here it is variance. So that means new variance, it is equal to 13. So we can write from here that 169 plus 13 times 30 equal to 15 times 158 plus 15 times x plus 196. So here it will be 2 and then it will be times 2 equal to 158 plus x plus 196. That means it will be equal to 4 and this will be 36 equal to x plus this will be 4, then 354. That means from here we can say that the value of x comes out to be 10. So the variance of the second set, that is x, is equal to 10. This is the correct answer for this question. I hope you understood the concept behind this question. The next question says that let y equal to yx be the solution of the differential equation dy dx equal to this. If y1 is equal to 1, then the greatest integer less than or equal to y3 will be what? Okay. So let us first solve this differential equation. So dy dx we can write by dividing both numerator and denominator by x cube. So 4 times y by x whole cube plus 2 times y by x plus this will be 3 times y by x whole square, then 1. Now this is the homogeneous form, so we can simply put y equal to vx. So dy dx will become v plus x dv dx. So it will become v plus x dv dx is equal to 4v cube plus 2v divided by 3v square plus 1. So it will be equal to x dv dx equal to 4v cube plus 2v minus 3v cube minus v divided by 3v square plus 1. So we can arrange the terms as 3v square plus 1 times dv equal to dx by x and divided by this equal to v cube plus v. Now we can integrate both sides separately. So this will be log v cube plus v equal to log of mod x plus this c we can write as log of k. So this we can write again as v cube plus v equal to kx. So v we have to again substitute back to y by x. That means y cube by x cube plus y by x equal to kx. This is the general solution. So let us first use this information to find this value of k. So y of 1 equal to 1, that means 1 by 1 plus 1 by 1 equal to k. That means k is equal to 2. So our solution becomes y cube by x cube plus y by x equal to 2x. So we can write this as y cube plus this will be, if we multiply both sides by x cube, so x square y equal to 2x to the power 4. Now we are asked to find the greatest integer less than or equal to y of 3. So from here we can put x equal to 3. So here we will get y cube plus this will be 9y equal to 2 times 81, that is 162. Now how to find or approximate the value of y from this? Now we have to apply the concept of applications of derivatives. Let us consider this function as f of y. Okay. So f of y is y cube plus 9y. Now f dash y will become 3 times y square plus 9. So it is positive for all y. That means f of y is an increasing function for y. Now if it is an increasing function, there has to be at most one point where y takes the value y naught such that y cube plus 9y equal to 162. So how can we approximate that value of y? Let us check f of 1 first. F of 1 is simply 10. So f of 2, let us check that also. It will be 8 plus 18, so 26. F of 3 will become 27 plus 27, so 54. Similarly, f of 4 will become, this will be 64 plus this will be 36, that is 100. Now f of 5 we can similarly check, it will be equal to 125 plus 45. So this is equal to 170. Now we can surely say that if f of 4 is 100, let's say this is the point 100 and this is the point 170, then this 162 lies somewhere here. So this will be 162. Now as y is an increasing function like this, so if y attains the value 100 at y equal to 4 and this here it attains the value 170, so 5. So that means there is some point between 4 and 5 where y cube plus 9y equal to 162. So this point, let's say alpha. So alpha belongs to the interval 4 to 5, and it is not equal to 5, but it cannot be also equal to 4. But we are asked to find the greatest integer less than or equal to this. So y of 3 is alpha basically. That means the greatest integer of alpha will be equal to 4. So 4 is the correct answer for this question. I hope you understood this question. Let's proceed. This is the last question of this mock paper. It is saying that let d equal to this determinant. Then the remainder when d divided by 2025 factorial whole cube is divided by 2025 is what? So we have to find the remainder when this quantity is divided by 2025. So let us decode this quantity first. So this quantity will be d by 2025 factorial whole cube. It will be equal to 1 by 2025 factorial whole cube times this determinant. Now this determinant we can take out 2025 factorial from all the columns. So here it will be 2025 factorial whole cube. Then inside this determinant there will be 1, then 2026, then 2026 times 2027. Here it will be 2026, then it will be 2026 times 2027, then it will be 2026 times 2027 times 2028, and inside this column there will be 2026 times 2027, then 2026 times 2027 times 2028. Then here it will be 2026 times 2027 times 2028 times 2029. So this determinant will be this. Now these two cancels each other. So we get this quantity as equal to, now from here we can also take out this 2026 out of this second row, and also 2026 times 2027, this two quantities from the third row. So this will be equal to 1, then 2026, then 2026 times 2027, then it will be 1, then 2027, then 2027 times 2028, and here it will be 1, then 2028, then it will be 2028 times 2029, and outside the determinant there will be a term 2026, then multiplied with 2026 times 2027. So basically whole square of this times 2027. Now we have to simplify this determinant. How to simplify this? Now let us subtract this row from this row, and also subtract this row from this row. So the second row remains unchanged. That means the determinant becomes 2026 whole square times 2027 as it is. Then inside the determinant will be, this will be 0, then minus 1, then it will be, if we subtract them, it will be minus 2 times 2027, and then here it will be 0, then it will be 2, sorry 1, then it will be 2 times 2028, and here this row remains unchanged. So now we can again add this first row and third row to simplify this determinant. So this will become 2026 whole square times 2027. Then inside the determinant, if we add this first row and third row, we will get 0, 0. Then it will be 1 times 2. So 2. Then here it will be 1, 2028, then 2027 times 2028. And this third row will become 0, 1, then 2 times 2028. Now we can simply open up this determinant because here it is simplified. So this will be 2 times then 1 times this. So the value of d by 2025 factorial whole cube comes out to be this. Now we are asked to find the remainder when this term is divided by 2025. How can we find that? By applying the property of remainders. Now we know that if, let's say, three terms are multiplied together, three numbers, then if we are to calculate the remainder when this product is divided by some other number, let's say r, then we can simply multiply the remainders when the terms m, n and p are individually divided by r and the remainder is taken. So it will be equal to remainder m times remainder of n times remainder of p. This we can use here. So here, if we divide this 2 by 2025, we will get the remainder 2. Then multiplied with, when we divide 2026 whole square by 2025, we will get a remainder of 1 square. So 1. Then when we divide this 2027 by 2025, we will get a remainder of 2. That means our answer comes out to be equal to 4. So 4 is the correct answer for this question. Now in this question, you can observe a really nice thing that if d is of the form, let's say n factorial, then n plus 1 factorial, then n plus 2 factorial, then n plus 1 factorial, then n plus 2 factorial, then n plus 3 factorial, then n plus it will be 2, then factorial, then n plus 3 factorial, then n plus 4 factorial. If this determinant is d, then d by n factorial whole cube minus 4 is always divisible by n. This thing you can observe here. I hope you understood this question.